Hello guys, I'm Alukoshao Enoch and welcome to another math tutorial session on differentiation and integration. Okay, this tutorial class actually feature additional mathematics 0606 IGCSE additional mathematics. Okay, so it also help you in IB PSAT and AISL exam style question. So let's take a look at the first question here, guys. So the question reads the diagram show part of the curve y equals to x sine x and the normal to the curve are the points p pi over 2 comma pi over 2. The curve passes through the point q pi comma 0. So the question one says that show the normal to the curve at point p passes through the point q. Show that the normal to the curve at p passes through point q. Okay, so and the second question says that given that this dy dx cos x equals to this, and we should integrate this, and finally we have to find the area of the shaded region. Okay guys, to get started with this question, we have to show the normal. We have to show that the normal to the curve at p passes through point q. Guys, to do that, let me just complete the task with my art pen, guys. Okay guys, don't forget that equation of is in coordinate geometry, you recall that y minus y1 equals to m into x minus x1. Okay, and that m is the gradient, guys. Don't forget it. M here is gradient. Now, so the first thing we have to do here is to go ahead and work on this function. Let me put that in a rectangular box. So we have to work on this function y equals to x sine x. Okay, because this equation actually is for where the equation of this curve here. Okay, so that is x sine x. Okay, so now to get the gradient for this function at point p pi comma 2 and pi comma 2, we have to differentiate this very function here. So let's go ahead and differentiate the function now. So I'm going to differentiate this function. So find the y dx, then I will now substitute this coordinate here, then I'm going to get my m here. Okay, so now I don't know, should I do it down here or down? Okay, so let me just put it in this rectangular box. Let me complete my differentiation here if possible. Okay, so let's go ahead and do that now. So I'm giving y equals to x and x, then the y dx. Guys, don't forget this is product rule. So its product rule is like x times sine x. So you are going to use product rule. Guys, I will not be careful to waste my time, guys. You trust me, we go with some shortcut method, guys. So now the rule says that product rule says that differentiate the first one, multiply by the second one, then differentiate the second function, then multiply with the first function. The first function here is algebraic function x, so multiply by the second function, which is freak function sine x, then differentiate the second function, then times first one. So differentiate x, that will give me 1, multiply by the second function, that is sine x, then plus differentiate the second function is sine x, so differentiate sine x, that will give you cos x, so plus cos x, then multiply by with the first function. So let me write down. So since I want to differentiate the second function, multiply with the first function, so let me just write the first function, that is x, then times differentiate the second function now, so that will be cos x. Guys, hope that rule is cool. So differentiate the first function, multiply by the second function, plus differentiate the second function, multiply with the first function. So I'll end up with what? Sine x plus x cos x. So guys, if you like, you can go ahead with your u dv plus v du. Guys, I don't have time for that. So sorry about that, guys. Okay, so just like integration by part simplified form, you know how I enjoy that section. Guys, let's continue. So what I did is that differentiate the first one, multiply by the second one, plus differentiate second one, multiply the first one. So the y dx here now gives me sine x plus s cos x. Now the next thing to do now is to go ahead and find the value, because we need the real value, okay, exact value for this. Okay, so and this is when x equals to, let me use arrow to do that now. So substitute to get our gradient, point value for gradient, substitute for the value of x, so where x is pi over 2. So anywhere x equals to pi over 2, then that should give us gradient. So finally gradient, which is the same thing as the y over the x, equals to sine pi over 2. I don't know, should I just plug that in my calculator without wasting time? Guys, I think this is video and you are listening to what I'm saying, guys. So I don't want to write that. So anywhere you see sine, sorry, anywhere you see x, just put pi over 2. Let me just put that arrow there. I don't need to put arrow, guys. Let me just say put um put x put x to be equals to pi over 2 in this function in order to get the exact value. So I'm going to plug this in my calculator straight now. So sine pi over 2, sorry about that. Sine pi over 2. Pi over 2, guys, I don't want to convert my calculator to radian because I can work in degree. Don't forget that pi is same thing as 180. So, but if you want to use pi over 2 etc like that, then you have to work in radian. You press second function shift. But I don't want to alter the settings of my calculator. So I work in degree. So because I know that pi is 180 degree, okay, from my knowledge of trig function, guys. Okay, so pi is 180. So what I'm going to do now is sine 180 plus sorry, sine 180 over 2. So 180 over 2 will be same thing as 90, guys. So I think I'm making it, this is a simplified form. So what I'm going to do now is sine 90 plus 90 cos 90. So that way I'm going to do, because I don't want to change my stuff to rad. Okay, so we go with that. That is sine 90 plus 90 cos 90. So sine 90 plus 90, so that is 1. So gradient here is 1. Guys, if you want to work with pi over 2, then you have to press I don't know, mode shift and go ahead, and because my calculator here, then go ahead and work in rad. So the gradient is 1 there. Now, but if you look at this question, see that this curve, the diagram show part of the curve y equals to x sine x and normal. So don't forget that when you have normal to normal means perpendicular. Normal means perpendicular, okay? So and if you can recall from our knowledge of straight line function, so when you have a gradient of 1, let's say mb, gradient of the second line of a line perpendicular to other line will be minus 1 over the gradient of the first of the given one. So now since so the gradient for this line will now be y, because I'm finding this equation for straight line, this equation for a straight line, okay? So I'm passing through this point. Okay, so now I now have, and it's perpendicular to this curve. So meaning that the gradient I'm going to use here, let me just call this one MA. So MB will just be minus 1 over 1. So MB, which is equation of the line, so that will be minus 1. Guys, hope you are still cool with straight line equation etc. So what I'm going to do now, I'm going to now complete the equation now. So y minus y1. So my y1 here, you can label this one now x1 and label this one y1. So you can just complete the label now x1 y1. So let me just use that arrow to just show you. So then anywhere you see x1, put pi over 2. Anywhere you see y1, put pi over 2. So y minus pi over 2. Now this is equation of normal to the curve. Okay, so normal to the curve, you are not going to use this gradient, to use the gradient of normal. So that is minus 1 into x minus pi over 2. Guys, hope that is clear. So finally my equation will be such that I'm going to end up with something like this. So just you can use why I solved the formula here before I do anything else, or I can also leave this one because say that the curve passes through the point Q. Okay, we have to show that this we have to show that the normal to curve at P passes through point Q. So to show that it passes through point q means that we have to justify that the coordinate of q is pi comma 0. We have to justify this coordinate. We have to justify this coordinate here. So let me just complete my equation here now. So let me just, I don't need to wait. Okay, let me just make y of the formula. So y minus, or let's say y equals to, if you open up this one, you have minus x. Is that clear? Then this one will be plus pi over 2. Your minus 1 times pi over 2 will give you plus pi over 2. Then I'm moving this one from the left hand side to the right hand side. So plus pi over 2. Guys, hope that is clear. So I end up with what? So y equals to, if you don't mind, you can just write pi minus x, or better still, minus x plus pi. Minus x plus pi. So this will be the equation now. Can I put that one in a rectangular box too? So this is what we have in here. Okay. So now guys, for us to show, we are now to show that the normal to the curve at P passes through point Q. So I'm to verify that the intercept, okay, the one intercept here is pi. Okay, because I'm sorry, that is when y equals to 0 here. You know, when y equals to 0, then I should get pi. So when y equals to 0, then my x should be pi. When y equals to 0, my x should be pi. This one here is the intercept on x now. At this point q here. At this point, y equals to 0. So when y equals to 0, what is the value of x? So if the value of x is pi, then that justify what we are to prove. So when y equals to 0, if I answer for, sorry, y should come second. Sorry about that. So when y is 0, because we normally write x comma y, x come before y. So our x value should be pi when y equals to 0. Our x value should be pi when y equals to 0. That is, the answer for x here should be pi. Okay. So now from this equation now, put y to be 0 now. So when y equals to 0, I will have, okay, I will end up with, let me write the right hand side first. So minus x plus pi equals to y. And y is 0 equals to 0. So I will end up with what? Minus x equals to minus pi. Such that x equals to pi. So that's proof. So meaning that the curve passes through the point q pi comma 0, because when y equals to 0, x equals to pi. So proof, guys. Proof. Can you just put there? Proof. Proof. Proof, guys. Proof. Is proof. So that is the justification. Okay, guys, let's go to the next question. Given that the differentiation of x cos x equals to cos x minus x sin x, we have to integrate this. Guys, I'm not going to follow this. I will not use this. I will not bother myself with this int given. The examiner is of the opinion that, guys, I don't know how to complete question on integration by parts, but thank God before now we have a video on integration by parts. Integration by parts simplified for all. So I'm going to work with that, because this one is like x sin x, which is a product algebraic multiplied by trig function. So this is a product, so it means that you use integration by part. So I know how to complete any question integration by part. Guys, if you don't know how to do that, guys, you have to go back to my first video on integration. But just go ahead and watch integration by parts, part 1 and 2, k calculus simplified for all, and you understand this better. So I'll work with this now. So question II now. Now don't forget that we use light. Okay, if you don't, let me just quickly recall light. So and L is the lean or logarithmic function. I is inverse function. We can, this one you can take it alternatively. It could be I first before L. Is relative. Okay, it will not affect. And also T also can be relative too, but algebraic function. So this is logarithmic or lean function, inverse function, algebraic function, trig function, and exponential function. I want to see the one that will take the differentiation preference. So now here I have algebraic against trig function. So algebraic will be under differentiation. So the function I'm going to differentiate will be under this column, and the function I'm going to integrate will be under this column. So since I have algebraic function against trig, so algebraic take preference over trig. So x will be here, and I can have my sin x here. Then don't forget to do your plus minus stuff. So now differentiate x, that will give me 1. Differentiate 1, that is 0. Differentiate, sorry, integrate sine x, that will give you minus cos x. From the knowledge of when you differentiate sine x, give you cos x from that knowledge, okay, and vice versa. So then I'll keep this minus now. So integrate cos x, that will give you sine x. I think I'm good like this. Okay, so we now put your operator now, plus minus plus accordingly. Okay, then how do we take it now? Don't forget from our knowledge of integration by parts. So this one multiply this, and this one will multiply this. So the answer to this question, I will now be what? So the answer here would be, can I just write the answer here now? Let me just write the answer, equals to. So this is I can write the positive parts first if you don't mind. So minus 1 times minus sine x. So that is sine x. Whoa. The best thing for me is I don't want to mess up with my work. Let me just put my answer in here. Let me put my answer in here. Okay, so finally I have what now? So I can want to work with this one. So that will be sine x, then plus times minus plus. So minus x cos x. And since this is indefinite integral, you just put plus c. So that's the solution to this question. So finally, find the area of the shaded region. Guys, so find the area of the shaded region. You see that the curve is above the line. So you are going to do, you integrate. Where can I complete that? So let me just put it here now. So what we are going to do now is to integrate the curve function, and we are going to take the interval from pi over 2 to pi. So see the x here, x1 to x2. So from pi over 2 to pi of the curve function, which is x sine x, and I have it already here. I have the solution up here. So x sine x, sorry about that guys, x sine x, okay, then minus, now this area of this line, okay, which is a triangle. Now let me just show you something now. So we are going to do area of this one minus area of triangle, and the area of triangle also. Let's see, let me just show you something here. Now if you look at point P here, if you look at this point P, trace it down here, and if you trace it down here, we are giving the coordinate for point P to be pi over 2. The coordinate for point P is pi over 2. So mean that the x coordinate here is pi over 2, and the y coordinate here is also pi over 2. Is that clear now? So the triangle we are taking look at now is, this is the triangle now. Can I just use this line? Look at this. Oh, sorry about that. I meant to use transversal line. That is pi over 2. Look at this. Pi over 2. So now, area of this triangle now, because when you do area of the, or better still, you can do area of the curve minus area of this straight line. So, and which is nominal to this now, area of the triangle now. Okay, so and that will give us the area of the shaded region. Okay, so area of the shade, that will give us area of the shaded region. So this is the shaded region. So area of the curve minus area of this triangle will give us area of the shaded region. So what is the area of the triangle? That is r base times height. So I think I should complete that one some here, guys. I'm sorry, I just need to manage my board. So I'll complete the area of triangle here now. So area of triangle is half base times height. So that is half. The base now, that is from 0 to pi. So half times. Guys, hope you are following. Hope that is clear, okay? So that will be half times pi over 2. Okay, times pi over 2. That is the base. Then times the height. Look at the height also. From 0 to pi over 2 times pi over 2. So that will give us pi square over 8. pi square over 8. So I'm going to do this one minus pi square over 8. Now this one here now, I have the solution to integral of x sine x up here. So in this function here, what I'm just going to do now is I don't know how much I can manage my board now. Okay, but it's cool, pretty cool, guys. I just need to explain because of our time. And this one now, since I have the integration already, I don't need to start doing the integration of this already again. Sorry about that. So what I'm just going to do is that in this function, I will substitute pi for the entire function minus, when I substitute pi over 2. So when s equals to pi minus when s equals to pi over 2 for the same function. Okay, so let me just go ahead and use my calculator now. Sine pi minus pi cos pi, something like that. Okay, guys, don't forget that. So that's what I have. So sine pi, so let me just plug that one in the calculator. Sine shift pi, okay, um minus pi shift pi. Guys, there is pi on your calculator. Just I think that is against very close to answer below your calculator. I don't know the type of calculator you're using, guys. Okay, so sine pi minus pi cos pi shift pi. So close this one now. That gives me what? Okay, I may need not to use I may need not to use this now. Maybe I should not use the calculator. Let me just go ahead and just bring it out and show you what I'm doing now. So when you put pi in that value now, the minus when you put pi over 2. So what do we have there? So don't forget that I don't want to convert, I don't want to work in rad so that I don't work in pi. So my pi is 180. I know that one for certain. Okay, and pi over 2 is 90 if I'm working in degree. Pi over 2 is 90 if I'm working in degree. So I think I'll go with that. So what I'll just do is that sine 180 minus 180 cos 180. Okay, so and if you like, you can also do pi minus this. You still get the same. You should get the same answer, guys. So sine 180 minus 180 cos 180. Close the bracket. So that gives me 180. So when it is pi, the solution here will be 180, and which is same thing as pi. Interesting. This is very interesting. When you substitute pi in that function, you get pi or 180 in degree. So when you substitute pi over 2 now, so let me substitute pi over 2, that is 90. So that is sine 90 minus 90 cos 90. Close. And that gives me 1. So when you substitute pi over 2 here, and in this same function here, your answer will be 1. Okay, so the solution here now, I have the solution for this one now, for this range now. So I have pi minus 180. Sorry, pi minus 1. Pi minus 1 or 180 minus 1, anyhow you want it. Okay, for this, then plus x. When you substitute pi to pi over 2, our answer is pi, which is 180. Also, when we substitute pi over 2 into this same function, our answer is 1. And since this is 1 is pi minus pi over 2, I think you know how to do this, guys. I think I just need to show you what I'm doing here now. We are going to have this something like this. Sine x minus cos x. Then you now take your range now. Let me use my line now. We take the range, sorry, the limit from pi over 2 to pi. So now this now here, this is not sine x minus x cos x. Sorry about minus x cos x. So the limit of this, actually the answer is pi over equals to pi minus 1. That's the answer we got here. Pi minus 1 when I use my calculator. Then area here now. The area for this one minus area, so minus pi square over 8. Pi square over 8. So you can plug this one in your calculator. I'm going to leave my answer here finally. my answer is okay like this. I think I'll work with what I have. So my final answer is pi minus 1 minus pi squared over 8. I think I will not simplify it further because of my time. So this is the final answer here. But if I were to plug this one into a calculator now, let me just do that. Pi minus 1 minus pi squared over 8. That is 0.9078. So that here, if you want a real value function, 0.9078. So guys, I think for me, this is okay if your student writes something like wrote something like pi minus 1 minus pi squared over 8, is still okay, and if you give me a real value function, it's okay. So guys, that's the end of the first solution, guys. So let's go to the next question, guys. Okay guys, this is the second question here, and it reads: diagram show part of the curve y equals to ln x plus 1 minus ln x. The tangent to the curve at the point P 1 comma ln 2 meet the x-axis at A and the y-axis at B. The normal to the curve at P meets the x-axis at C and the y-axis at D. So find in terms of ln 2 the coordinate of A, B, C, D. Okay guys, to complete this very task, the first thing for us to do is to work on this equation here. Okay, so guys, don't forget this equation here. Okay, so now guys, to going to get the gradient from this equation, and don't forget to find the gradient of a given equation, you just go ahead and differentiate. Okay, so I'm going to, in order to manage my board very well this time around, let me just put it here. So I need to manage my board very well. Okay, so I'm going to find the y, the x now. So differentiate this now. So I will just just take it as y prime, guys. So because so that's right. So that's the y over the x. Okay, of this function. So when you differentiate linear function, you differentiate respect to ln. So that is 1 over x plus 1. 1 over x plus 1. It's a function of function, then times function of the algebraic is x plus 1. So when you differentiate x plus 1, that will give you 1. So times 1, it will not affect it. Okay, so I'm done with that. Then minus differentiate ln x, that will be 1 over x. Guys, that is cool. Okay, now so at point P equals to 1 comma ln 2, so the x coordinates now, so to get the exact value for the gradient now, so just go ahead and substitute the value of x. So when x equals to 1, so as x tends to 1, when x equals to 1, what do you have here? So your gradient will now be 1 over 1 plus 1 is 2, 1 over 2 minus 1 over 1, that's 1. So eventually we have the gradient for the curve now. Let's take it as m1, so, or ma as you like, no problem, but let's just take it as ma. So letter A. So ma will give me what? Minus half. That is the equation for the the gradient for the curve. Okay guys, now if you read on, the tangent to the curve at the point this meet at x-axis. So now tangent to the curve this here now, this tangent to the curve BA. Okay, so now let's go ahead and find the equation of that line. So the equation of the line is giving us, let me put that one in a rectangular box also, such as to be able to manage my board very well. Let me put it in a rectangular box also. I think I should be able to complete everything here if possible, I believe. Okay, so let's go ahead and do that now. So y minus y1, y minus y1 equals to, so mb now is relative. It depends if it is perpendicular or tangent, or if you like you can say normal, or to the curve, or tangent also. So normal is the same thing as perpendicular, while tangent is parallel. Mathematics and additional mathematics. So in additional mathematics we use normal and tangent, and in mathematics we use parallel and perpendicular. So mb into x minus x1. So this is the general equation for a straight line. So equation of a line tangent or perpendicular to the other one. Okay, so now I have y minus y1. My y1 here, you can label this one now. This is my x1 and this is my y1. So 1 and ln 2. So y minus ln 2. Now since this is actually is a tangent means it's parallel. Okay, so mean that I'm going to use this, because in that case ma equals to mb. If it's tangent, MA equals to MB. Don't forget. MA equals to MB. But if it is perpendicular, M equals to, let me just put that down so that I don't need to do that again. So, but if it is perpendicular, MA will be minus, sorry, MB will be minus 1 divided by MA, the negative inverse of the first gradient you have, which is this one. Something like that. So I don't need to quote this again. So equals to, so I will still continue with this minus half because it is tangent, so it's like it's parallel to it. So x minus x1, and my x1 is 1. So I think I don't need to use y as subject formula. I'm going to leave it like this, but you can go ahead and use y as subject formula. You have minus half into x minus 1 plus ln 2 because of my time. Okay, so this will be the equation I'm going to use through now. So now the tangent to the curve at the point P of this meets the x-axis. Now x-axis, that is A. So the coordinate for A, let me just use it here. Let me just do it like this. So at A, at point A, at A now. Since it is x-axis, so it is it's going to have x is a boundary point on x. So this is x. Then the y will be 0. So x comma 0. Okay. So at x comma 0 now, use this equation now. So where this x equals to 0, so you continue with your y1 and x1. Okay, so your x is 0 in this one here now. Okay, so now, so what do we have at A now? So at A now, we have y minus y1. I'm still working with this equation now. So y minus y1, and my y is 0 here now. So my y is 0. So that is, I'm looking this one now. So 0 minus my y1, this is my y1 here, ln 2. 0 minus ln 2. I pray I'll be able to manage it very well, okay? Equals to minus half, because it's equation of tangents, so I'm using this equation, minus half into x. So I'm looking for x now. So when y is 0, what is x? So x minus x1. x1 is 1 minus 1. So I'll use x subject of formula now. So if you don't mind, I'll just take that one there. So I can divide both by minus half here now. So if you divide both by minus half now, I can write x minus 1 first now. So will I be able to manage this thing very well? Let me just demarcate. Let me demarcate these things so that I'll be able to use the other line again. So let's continue with that. So let me continue on this line. So now divide both. So since I want to use x of your formula, I can put that one on the left hand side. So x minus 1 equals to, so divide this one by half now. So that will be half ln 2. Because negative, you can cancel negative. Do you understand what I did? Okay. So such that x will now be, if you don't mind, I can do half ln 2 plus 1 and vice versa. Half ln 2 plus 1. Half ln 2 plus 1. So finally, the coordinate here now, this one will now become what? So the solution here will just be half ln 2 plus 1 comma 0. Half ln 2 plus 1. And sorry about that, guys, comma 0. I don't know if that is pretty cool, huh? Plus 1 comma 0. So that's the coordinate. So when y is 0, then x will be the coordinate for x will be half ln 2 plus 1, guys. So coordinate for a now, so therefore a coordinate will be what? Half ln 2 plus 1 comma 0, or 1 plus half ln 2. I'm through with that. Okay, now let's do the same thing for at point B. Okay, at point B, at B, and that is y-intercept, right? Because say that B is y-axis, so boundary point y-axis. So on that, on y-axis, x will be 0, so that will be 0 comma y. So I'll look for the value of y when x equals to 0. Then I'll also use the same equation here. Okay, so I'm looking for y now. So you do y minus y1. So y minus ln 2, that is y1. Don't forget here. Y minus ln 2. Okay. And since you are still dealing with tangent to the curve, so we still continue with this. Equals to minus half into x. So x is 0 already here. 0 minus x1, that is 1. So here I want to use y subject formula now. So y equals to this one now. Use minus half to open up. You have half minus half times 1 is half, then plus ln 2. So the coordinate for b now at b, the coordinate here will now be let me just put it here. Sorry about that. This is arrow. So the coordinate for b now, when x equals to 0, then y will be ln 2 plus half, or half plus ln 2, either way. Since I do write my ln first, so let me go ahead with the ln function. Ln 2 plus half. So that's the coordinate at b. Okay, because this question actually asks us to find ABC, so I'm through with AB. So let's go for C now. Now, but if you look at for C, the normal to the curve at P meets this. Okay, now so this is normal to the curve, unlike here that we have tangent to the curve. So for normal to the curve now, I need to get a new equation here. I don't know if I should swap and change the color now so that we differentiate between normal and tangents. Okay, so let me use blue color. Okay. Okay, so let me just demarcate that. Sorry about that. Let me just demarcate this. Okay, so now the equation for normal to the curve is what I want to write now. This is the equation for tangents. So for normal now, I'm going to have y minus y1 okay, because we still have this point P there. Okay, so y minus y1, that is ln 2. I'm correct, right? Y minus ln 2. Sorry about that, guys. Equals to, now equation for normal to the curve now. So this will be minus 1 over minus half. So minus 1 over minus half. Let me use my calculator. I don't need to use that. Oh my god. Okay, that will be 2 though, because it's negative. Minus 1 over minus half will give me 2. Guys, hope you are clear with that. So that will be 2. That will be 2. Okay, but let me just write this minus 1 over minus half. So that will be minus half, minus 1 times minus 2 over 1, and that will give me 2. So the gradient I'm going to use here will be 2. So instead of minus half, so I'm using 2 now. So equals to 2. Oh, sorry about that. I'm writing it in. Equals to 2 into x minus x1. So this is the equation I'm going to use to complete D, C, and D. Just like there's nothing here. Don't forget that. So now let me just demarcate this, and I think I will be able to complete this now. So I'm working with blue now. Okay, never mind. So at C now. At C, at point C. Do you understand that? So at C now, so what is the coordinate? Because okay, that this one says that meet the x-axis at C. So x-axis at C means that I have a boundary point. Okay, so this on x-axis s comma 0. When y equals to 0, we are looking for the value of x, given this blue equation. When y equals to 0, what is x? So let's complete it now. So if you don't mind guys, because I just need to manage my board, if you don't mind, let me just complete it here under this place here, in this rectangular box. Okay, so I'll get the coordinates for C here. So now let's just go ahead and do that now. So now I'm using this equation now. So when y equals to 0, I have 0 minus ln 2 minus ln 2. I'm looking for x, don't forget, equals to 2 into x minus 1. Well, you have the equation already right from here. So now I can, since I'm looking for x, I can write x minus 1 first. So x minus 1 equals to, this one is minus ln 2 over 2. So if you don't mind, I can write, yeah, let's just write like that. Minus ln 2 over 2. Or minus half ln 2 if you don't mind. Minus ln 2 over 2 is good with for me. Okay, so now what I'm going to do now is that I'm going to bring this one here. So when you bring this one here plus 1, then you're going to cancel out this one here. Sorry about that, I just need to manage my body. So x is now, I cancel this. So x is that. So the coordinates at C now, when x, that will be minus half ln 2 plus 1. So the answer here will be minus half ln 2 plus 1 minus 1 over 2, which is same thing as ln 2 over 2, guys. Minus 1 over 2 ln 2 plus 1 ln 2. And for some reason, my stuff is lagging, so I just need to, okay. So minus ln 2 plus 1, comma, 0. So that's coordinate for C. Okay, finally, let me go ahead with my coordinate for D. I think I'm cool now. I should be able to complete everything on this space. So at D now, if you go back to the question now, the question says that y-axis at D. Okay, guys, just a quick one. If you look at the solution to A here, because I'm looking for x minus 1 here, so if you cross multiply, this should actually be 2 times minus, okay, so be half, okay, I'm sorry about that. So this should actually be, I don't know if I can erase this now. This one here should be 2 x minus 1. If I move x minus 1 here, okay, this minus cancel this minus first, okay. So then these two move in here, so this shouldn't be half, this should be 2. I'm sorry about that, guys. So this should be 2. So 2 ln 2. So this should be 2 ln 2. Then when you bring this plus 1 here, so this should be 2 here also. This is 2. Not half. Sorry about that. Because you cross multiply, when you divide by half, it can't be half, okay? So this is actually 2. This is 2 here. So sorry about that, okay? So this is 2. 2 ln 2, okay. So we can continue with that now. So my B, everything is okay now. So now the next one says, if you look at the one here, the normal to the curve at P meets the x-axis at C. So we confirmed that already, and we have the equation that we're going to use here. Okay, so we have the equation here already, and we've got it for C. So let's go with D now. So at D now, at point D. So I don't know why I changed to this red. Okay, sorry about that. So at D now, okay, we have y-axis. So y-axis, that is on y-axis, so x will be 0, is a boundary point on y-axis. So x is 0, and we have y value. So we are looking for y when x equals to 0. We are looking for y when x equals to 0. Okay, that's clear. So we are looking for y when x equals 0. So we work with this blue solution accordingly. So I have y minus y1 is ln 2 minus ln 2, okay, equals to 2. Don't forget we are working with blue equation, okay. So into x, now this is when x equals to 0. 0 minus 1. So go ahead and use y as subject of formula here now. So then I have y equals to, if you use 2 to open up here, you are going to end up with minus 2 here. So if you bring this one here, that will be plus. So that will be ln 2 minus 2. Ln 2 minus 2. So I think I would like to swap back to this blue and to get, so the coordinate there now. So at D now, at D, when y equals to 0, wow, This is lagging, huh? Okay, so when x is 0 now, so what is y? So we have the value already there, so I'll just use this arrow here. So then when x equals to 0, that'll be 0 comma lane 2 minus 2, lane 2 minus 2. Okay, I hope that is clear. So now we are through with the first um question. So we have the coordinates for A, B, C, and D now. So now the next question says that given that the area of triangle PBD. Okay, guys, look at the second question. Says that given that the area of triangle BPD divided by area of triangle ABC is 1 over k, express k in terms of lane 2. So guys, don't forget that to complete this task, we need the coordinates for A, B, C, and D accordingly, also the coordinates for P. So guys, you may need to watch my video on intercept equation of a straight line, and to um, get yourself acquainted with this method I'm going to use now. So guys, don't forget, so I will just put the coordinates here now. So now for the first one, now I'm going to work with this numerator here, b. So what's coordinate for b? B is 0 comma half plus lane 2. So you write the x coordinate first, 0, then the y coordinates down, that is half plus lane 2, half plus lane 2. That is the coordinate for b, because we want to do bp, then the next coordinate is p. The coordinate for p is 1 comma lane 2. So 1, then lane 2. Then let's look at the last one, d. So the coordinate for d here, this is coordinate for d here, and that's 0, 0 comma minus half plus lane 2, minus half, sorry, minus 2, sorry about that, minus 2. This is minus 2 plus lane 2, or lane 2 minus 2, either way, minus 2 plus lane 2. Then you now repeat the first coordinate. Repeat the first coordinate. Sorry about that. I don't know if I should clean this if possible. Can I clean? Okay, it's not working for me. No problem about that. So let me just go ahead and complete it now. So I'll repeat this one, which is 0, and then half plus lane 2. So guys, I'm sorry, this one here will now come here like absolute value, so that you don't get negative answer. So I cancel this one here. Then you can go ahead and do your operator now, plus, minus, plus, minus. This is how to find the area of any polygon with given coordinates. Any given polygon with given coordinates. Okay. So then let me start with the first one now. So you work with the first here. So you do the red now. So this, sorry about that, I need to take that line again. So this multiply with this, that will give you 0. This multiply with this, and that will give you 2 minus lane 2. And this multiply with this, that will give you 0. So the first part of the answer we have here will be this. Okay, so that is 2 minus lane 2. That's what we have there. 2, because this is sorry, this is negative. Okay, so this is negative, so minus, so this is 2 minus lane 2. Hope that is clear. Because b is half plus lane 2. So b is half plus lane 2. Okay, and this is b here. Then we have p, that is 1 lane 2, 1 lane 2, this one here. And then we have d rather. So and d is 0 minus 2. So this one will make this one to be plus, and this one will make this one to be minus. Okay, that is clear. So I have these answers here. Then you now do minus, then open a new bracket now, and I'm going to use blue to do that now. I'll use blue to complete that. Minus. Then you now reverse the case now. This multiply this. I think I changed that into blue. I'm sorry about that. Will it work now? Because I so that you guys will get to understand what I'm doing. I want to change the color. Yeah. So this multiply this. Okay. Um, this multiply by this. How come this one is just linked to like? Okay, yeah, it's correct. And finally, this one here, which is 0, we multiply this. So this 0 we eliminate. So the only thing I need here is this minus. Okay. So you can open a bracket in order not to make mistake. I can just open a bracket here. So minus, just open a bracket here. So you have minus half, minus ln 2. I think that's clear. Then close the bracket now. So if you look at use minus to open up this one up, this become plus and this become plus. So therefore you have minus ln 2 plus ln 2. So that will be gone. Okay, and this one is 2 plus half. So 2 plus half will give you what? 2 and a half. Okay, so 2 plus half is 2 and a half. That is 5 over 2 if I'm right. 2 and a half is 5 over 2. So I have 5 over 2 here. So therefore the gradient for the up one is 5 over 2, guys. So I can write here now. So this equals to 5 over 2, then divided by, then area of APC now. So I'll do the same method now, but I'll continue with blue. So area of APC now. So this absolute value here, I don't need to close it there, so it's going to contain it. So now, just the same way, we start with A. So what's coordinate for A? A is 1 plus, the x coordinate there is 1 plus 2 ln 2, comma 0. I need to write that 2 very well so that I don't make mistake later. 2 ln 2, comma 0, so you write 0 down. Then P, this is P here, 1 ln 2, 1 ln 2. Then finally C, and our C is 1 minus half ln 2, okay, 1 minus half ln 2, that's the x coordinate, then comma 0, so you put 0 here. Then you end with what you start with, 1 plus 2 ln 2, 1 plus 2 ln 2, 2 ln 2, then 0. Then you can end the, I'll use freehand, sorry about that. So then you can now go ahead and do what we used to do now. So let me just go ahead with the blue arrow first. So this multiply this, okay, this will go to 0 and this will go to 0. So all I need is just this one, and it is plus if you want to start, sorry about that. And you don't forget that you alternate plus minus plus minus plus minus. So this is plus. I don't need to complete the minus one because they are 0. So the answer I have here will just be ln 2 multiply all this one here now. So that will be ln 2 times 1, that is ln 2, plus 2, then ln 2 times ln 2, that will be ln 2 square. Ln 2 square. So I have that. Then minus, then the red part now. So let me just open a big bracket here. Okay guys, the red part now, you see the red part. Let me just go ahead and use my this one here. So let's complete the red part now. So I think at this point I just need to complete the operator here. So one, we go for this this one here, we go for this, and finally this one here will go for this. So let me also complete the operator now because I need this time around. So minus, plus, and minus. So let's complete the red part now. So this is 0, so no problem about that. So now I can use ln 2 to open up this one now. So that will be ln 2 times 1 will be ln 2. So ln 2 minus half, then ln 2 square. So I think I'll put it in brackets like this, ln 2 square. So that be the solution to that. Then this one will go to 0. So now let's get the final solution here now. So I have lane 2, this minus lane 2. So this will go with this minus will make this one to go. Then this is minus, so it makes this one to be plus. So you have 2 lane 2 square plus half lane 2 square. That is 2 and a half lane 2 square, which is same thing as 5 over 2. 5 over 2, because 2 plus half is 2 and a half, which is same thing as 5 over 2. So 5 over 2 lane 2 square. Guys, hope that is clear. So now that is the solution to the area of triangle APC. APC? Why not PDP? Okay. So sorry about that. Okay. So now let me just put this now. So divided by, so area of triangle BPD, which is 5 over 2, divided by area of triangle APC. Guys, APC is like APC. I can't imagine APC in this question. Okay, so lane 2 all square. And this is a mistake, guys. I don't know why. I just play fool. Lane 2 all square. Just not the, it's not the 2 that is square, it's all square. Lane 2 all square. And I'm not sure if my razor will avail now. Sometimes this board just, oh, okay, thank God. So lane 2 all square. Okay, so what do you have there now? So this is 5 over 2. Cancel this 5 over 2. That is 1. Okay, and this our answer is coming as 1 over k, and k is lane 2 all square. So I will equate this one to be 1 over k. So the value of k now, let's say express k in terms of lane square. So k will be what? Lane 2 square. That's the answer. So k is lane 2 all square. Guys, this is the end of this tutorial now. So I think at this point, because of our time, we are going to make part 2 of this video, guys. Okay, we are going to make part 2 of this video, and I will continue to solve the remaining questions in the part 2. So guys, let's, okay guys, here is my YouTube channel. Okay, so there are quite good numbers of video for you to enjoy here. Immediately after this session, I'm going to upload the video on differentiation and integration on my YouTube channel. There are quite good numbers of videos, mathematics, additional mathematics, robotic and coding, ICT, that will actually help you. Okay, so guys, you can see something like integration by parts, calculus simplified for all. This is some graph of trig function, simulating binomial distribution. You can also create your game using Scratch programming. You can develop AI using Python, and this is transformation, and quite good numbers of this video on robotic and coding. So guys, just go ahead, and if you find any of my video quite useful and helpful, just go ahead and click like. You can also subscribe to my channel. Also, I'm going to upload the same, I'm going to upload the worksheet and some board work also on my test shop, and also the video also be available here. Okay, so and also you have quite good numbers of board work on ICT, mathematics, robotic and coding, additional mathematics here. And okay, most of the ICT and mathematics videos, board work and worksheets here are actually exam style question, GCSE, IGCSE, IB, diploma, and so on, A level. Okay, so guys, just go ahead and avail yourself. This is transfer application, quite good number sequence and rotation. So guys, go ahead and do well and take good care of yourself. If you find any of my also resources, e-learning resources quite useful, just go ahead and help to review the resource. Okay, like graph of trig function. Okay, so guys, do well and take good care of yourself, and do have a great day ahead. I love you guys. Bye bye guys. So let's end with this note, guys. Let's end with this note, guys.
Wake the streets up.